So first I start with the first idea, opposite angle identity. Notice one thing about the opposite angle. Only one of those is even. Can you tell me which function is even? Based on what you see. Which function is even? Cosine. Only cosine is even. Because if you look at cosine, you see that if you replace x with negative x, nothing happens, right? The other ones, if you replace x with negative x, you get an opposite value, which means everything is odd except what? Cosine. Maybe we show you cosine. Notice also that for the cosine behaves the same way as what? Secant, because they are what? Substitute. This one only even function. And what does even mean? Replace x with negative x, nothing will happen. Okay, let me show you the cosine real quick for you to see why we did. So this is alpha. Let's say this is alpha. But if this is alpha, we can say also this is negative what? This is negative what? I'm not sure. Let's say this is alpha. From here to here is alpha. So the cosine of alpha will be what? Or let's do this.
24.
And this is negative what?
Negative.
Negative. Notice that both of them have the same cosine, right? Watch. Both have the same what? The same what? You see it? Both cosine alpha and negative alpha. They have the same what? Cosine. But for other angles, it's not the same. Let me show you. So you see that the cosine is the same, right? Look at sine. If you look at the sine alpha, is here. That's the sine, right? And if you look at the sine negative alpha, is here, right? So you see that the sine is opposite, right? This from here to here is sine alpha. And this from here to here is sine negative alpha. This from here to here is cosine alpha. Also, same idea. From here to here is cosine negative alpha. It's very clear from all this that cosine alpha is the same as cosine negative what? It's the same thing. Cosine alpha, same as cosine negative alpha. And then a sine alpha is negative sine negative alpha, which means replace alpha with opposite, you get opposite values also. Pay attention to something. Even on the unit circle, you have the same thing. For example, remember the cosine, the pi over 4? If that was pi over 4, that would be square root of 2 over 2. And square root of 2 over what?
2.
And if that was negative pi over 4, or what's another way of saying negative pi over 4? So you can count in the negative, or you can, if you count in the positive, what would that be? 7 pi over what? 4. It's the same thing. You gotta look. You can look at it negatively or what?
Positive.
It'll be negative square root. It'll be square root of 2 over 2.
Negative.
Same cosine, different what? Different what? Based on this, we can do a lot. Let's try to do some simplification. So, this one is the only one that makes the cosine disappear. What about tangent and cotangent? But tangent and cotangent are also odd. Watch something interesting. Let's start with tangent. What is tangent alpha? What's tangent negative alpha? It is sine of negative alpha over cosine of negative what? But the sine of negative alpha is negative sine, negative alpha. Right? Which means when you replace alpha with negative alpha, negative sine of alpha. Replace alpha with negative alpha, the negative opposite what? Over here it will be just cosine what? But what is this? Sine alpha over cosine alpha.
Negative.
You see? That's why it's odd. Everything is odd. You have to keep the negative for all of them except what? Cosine. And then C. And let's see how we're going to use that factor to our advantage. So if I have cosine of negative pi over 3, that's the same thing as saying it is cosine of pi over what? Which is, what is the cosine of pi over 3? So this is how you're going to remember. Pi over 3 is 60, right?
Yes.
60 is shorter in the x direction,
Yes.
which means it is what? One what? That's why we say imprint the unit circle mentally in your brain. If it was cosine pi over 6, longer in the x direction, it would have been square root of 3 over what? 2. What about if it's other angles? Then you refer back to the reference what? So tangent of negative pi over 4. But tangent of negative pi over 4 is negative tangent of pi over what? So we need that negative here because it's it'll be negative square root of 2 over 2 over square root of 2 over 2. Negative what? 1. Because pi over 4 on the unit circle, remember pi over 4 is associated with square root of 2 over 2 and square root of 2 over what? 2. So if I have tangent of pi over 4, that will give you 1. Also, what else gives you 1? Cotangent of what? It gives you also what? This is how you, as a student on trigonometry, started to build what we call stamina, experience. Little by what? He didn't mention this, but I'll write it down. Also, if you see pi over, let's say pi over 6, okay? But the pi over 6 is associated with square root of 3 over 2 and 1/2, right? The x being the cosine and the y being the what? The sine. So tangent of pi over 6 is what? Is sine over cosine, right? So always sine over cosine really means 1/2 over square root of 3 over 2. But how are you going to do that fast? Just means 1 over what? No, 1 over square root of what? First I'll show because we don't have a lot of experience here. Square root of 3 over what? 2. That just means 1 over square root of 3 over square root of 3, right?
Yeah.
But you gotta multiply by what? Over what? So it'll be square root of 3 over what? 3. If I have cotangent of pi over 6, the cotangent of pi over 6 will just be this over this, right?
Yeah.
But this just means square root of 3 over what?
1.
Which is just square root of what?
3.
Now watch. That's for pi over 6, right? You watch, you need to work with trig for some time for you to like kind of get the idea. If you see that pi over 3 is just what? 1/2 and then what? So if you have tangent of pi over 3, in this case, you notice that the tangent of pi over 3 is going to be what? Square root of what?
3.
And the cotangent of pi over 3 is going to be what? Square root of 3 over what? You see how they kind of switch? Because pi over 3 and pi over 6 are called co-function angle, which means if you add them, you get 90 degrees. 30 and 60 is what? 90 what? That's why they switch, right? So pay attention. On the unit circle, we can get all kind of crazy things, okay? So watch something interesting. Let's say somebody is telling you, compare this. Compare cosine of alpha plus pi to cosine of alpha. Okay? So how will you compare this? First of all, where is alpha? Look, well, that's alpha is here. Let's say alpha is here, right? So where is cosine of alpha? Cosine of alpha is this, right? So now I want an approximation of where alpha plus pi is, right? This, from here to here is pi, right? And I gotta add to it what? Another alpha, right? Only alpha, right? That's, from here to here is pi, right? And then this is pi plus what?
Alpha.
So where is the cosine of pi plus alpha? How do those two compare? Opposites, right? So it is true that cosine alpha plus pi is equal to negative cosine what?
X.
Alpha.
I'm sorry.
You understand the comparison? But this you can do for all of them. Let's do the sine. But the sine of alpha is here. And the sine of alpha plus pi is where? Also opposite, right? So let's say somebody says, I want to do this. Cosine of alpha and then cosine of pi over 2 minus alpha. Okay? Where are those? Well, let's say alpha is here. And that will be cosine of what? That will be cosine of what? Where's pi over 2 minus alpha?
So that's fine.
So this is pi over 2, right? I'm going to take from it what?
The alpha.
So maybe right here, I don't know. Approximately, remember, right? So this, and now notice one thing. This is cosine of what?
Alpha.
It looks like cosine of alpha is the same as this, right?